Okay.
One
So
second. Yeah, I've started the recording now. You could proceed now.
Okay, sure, Lambe. Nice to connect to you. We met on to the Slack channels on the AWS, the community builder. So I'm the new born into community builder this time. We do a lot of activity. I'm coming from the Baroda, Gujarat. We run AWS user group here with my one friend Nirmal and many other community members. We have kind of like big self-governed community, and then we do a lot of activities here, in-person meetups as well as the large-scale community day celebrations. Part of that one, I also take a lot of community sessions, and then whatever I learned over my around 20 years of working with this various software development practices, and then move to the cloud, and then move to the observabilities, and transiting from the data center to the cloud AWS, and for hundreds of servers and the terabyte of data, and that's how I learned it. So whatever I learned, it is all practical thoughts, and then I'll share you my journey, how the observability in the real time looks like, and the where you need to go. Whenever I meet the people, okay, everyone takes and speak about the microservices. I develop a microservices. I do a microservices. So there are a lot of people who do the microservices. Basically, when they write a REST API, they call them a microservices. Probably that is probably not the entire the correct statement, or maybe the REST API should not call the microservices. There were many things goes when you really do a microservices, because it's kind of like what we call it's kind of like entire behavior of your applications. Because writing a REST services doesn't comes into the boundary. It is a one part how you serve the request, but when we call a microservice, it's kind of like a life cycle journey of the entire the component that you have built it, and then it's not always necessary that that component must be a REST API. Okay, it is a component which has the self-sufficient lifestyle, the scalability, usability, and then single point of the work assignment, a single responsibility component, and then all those components which are there, whether it's directly accepting the request over the some HTTP protocol or the other protocols, or it does some kind of the processing as part of the large data processing chain, and then all those components which basically call a microservices. Because when you have those components, it need to be built on such a way that it can scale up, scale down. It can adopt the traffic pattern. It can give you the proper insights, and then you can adjust and then give you the proper throughputs. So that is what I see microservices, rather than just categorized as the REST API. So that is what basically like what in short the microservices people should look like. So the way that I started this one, when we had a lot of legacy components over the data center on a traditional ways. I'll take a lot of examples of the Java programming, because I have come from the Java programming background, as well as also give you the other programming language context in between, because I have seen implementing towards the other programming language and the development models. So when you do a Java programming, it's kind of like have a lot of integrations and third-party softwares are implemented here, maybe or 200 servers set up, and then we moved into the AWS. So they were challenging. We were using the containerizations, so we don't know the where our logs are. When we were doing the containerizations, the client, the IT services people were tell how I do SSH to find my logs. Okay, because container you don't give it the SSH access to it directly, and they were not able to find it. So we had to come up with the entire observability management solutions. So we built it first Splunk. It was very expensive. So that was our first attempt. And then to cut down the cost, the AWS comes with the AWS OpenSearch software and an entire the ecosystem, which is basically like if you see this AWS OpenSearch, it started from the ELK 7.12 release, and then where they had a split in terms of licensing problems, and then AWS and open source community forked out, which is backed by the AWS, and then it's become AWS OpenSearch. And now it has its own the journey since that one, and it's become very mature. They added tons of extra functionalities to make a very large scale observability platform, and then they built an entire ecosystem. So that's why we moved our entire environment from the Splunk to the AWS OpenSearch. So let me get my presentations on, and so we can just go very light-hearted presentations. Everyone would like it. Just give me a second.
Are you able to share the screen?
Yes, just do it. I'll take my latest presentation. It was given into the recent AWS Community Day, Pune. I have a couple of versions of this one. Can you see the screen?
Yes.
Okay. So we'll speak about the microservice observability with the OpenSearch. I'll make you very light. Okay. Then everything that we want to do is the demo. Okay. So this is a topic. I'm Ravi Suni. I work as a Rusab Software. It's the Baroda-based software company, and I'm the cloud architect at that company. This is my just brief introduction. I call it a know your speaker because of the KYC know your customer. So here you should know your speaker. I have 15 plus years software development experience, hardcore Java programmer. I do the code to the cloud, everything together, maintenance, management, DevOps, everything at the very large scale systems. I recently built the AWS Community Builder this year. I am the OWASP member also, and then I do a lot of other stuff. I have 2 AWS certifications. I try to do it more, but I get a lot of other distractions, and so not able to focus and complete it. I'll wish to edit more on my deck. We'll talk in today's agenda, and let me know if my screen is visible correctly, or I need to scale it a bit.
You can keep it in the presentation mode if it's fine.
Yeah, yes. Okay, now it's good.
Yeah.
Okay,
Yeah.
so we'll talk about a very brief monolithic. Okay, how it looks like, what you do with the microservices, so how you transit it, and then why you need observability. Okay, the pillars of observability, what you definitely have. Okay, we'll briefly talk about the OpenSearch. OpenSearch is kind of itself is the ocean of the ecosystem. So we'll not go to very deep. There are so many things happens here. I will talk about the important sections of the things which you definitely need to understand how you build the observability. Okay, I have a sample applications, entire end-to-end working, fully functional. I have also hosted that entire applications over the GitHub. So if someone wants to play it with, just check out it, and then you can build this entire solutions in your local Linux box without any problem. Okay, so monolithic, I have built this kind of the monster, and those monsters survive over a decade, and then it's still working in my previous companies. So this is what the heavy lifters, what I call, rather than the small applications. Typically, it looks like you use enterprise Java components like EJBs and the messaging systems and Java application servers like either the WebSphere or the WebLogic or the Oracle IBM WebSphere. Yes, those are the heavy lifter components. So I have built it hardcore EJBs level of applications, and the performance, the stability, is mind blowing. I have built something over the Wildfly, which is have the Java application, then more than a year uptime. No transitional failures, no memory leaks, and if you don't touch applications and then don't go and don't log into the server, and then straightforward uptime is more than a year of the Java application, and that application process more than 10 million documents every day since a decade. So you can see how the big monolithic applications can do the heavy lifting. So I have built it. Then we transit and we see the character. It's like I call it spouse because it's have a longer life, very stable. Okay, operational cost is very predictable. We build it 2 servers of those cluster of Wildfly with the 32 gig RAM and the 8 CPUs on the AWS, and then hardware allocations is remain exactly the same level since a decade. But the documentation processing load is increased twofold. So when we initially started, we were having around 2 million documents. The same system is still able to handle the 10 million of documents, and then it's still running. So it very stable. Okay, you don't need to do any maintenance management. I call it as anniversaries. Okay, it doesn't freak out. Have enough power and processing capacity, so it keeps running. No problem. When you transit from the microservices, you make one large-scale elephant kind of system into the multiple small the pets. Okay, and then the one guy, basically a system admin, wants to manage and then have the keeping of and taking care of one animal, other than you are now deal with the hundreds of animals, because you take out all those components out from the one large scale system into the smaller component. As you do this transitions, your resource requirements are getting doubles and triples. So that's why it is getting expensive. It's getting very small, and when you make it microservices, which is basically a smaller components, okay, the life cycles are also very small, and you need a lot of maintenance management activity there. So this is how it looks like, and then it call it like a girlfriend, very freaked out. Okay, you need to do the pamper, very unpredictable. It scales up, scales down. Operational cost is high. I can show you how it looks like. Okay, if you don't forget the maintenance management, we call anniversaries gifting. Okay, and then definitely could go down, and we'll have a problem. So this is how, and we had this kind of system where the monolithic blocks still remain intact, but we had certain applications were turned into the microservices, and which was catering to the client services. Okay, and then many times we found that in the morning when the load is get increased at the in the US time around 7 to 11 in the morning sessions, they were freaking out. Okay, and then the boss comes into the office, call everyone's into this, like how exactly like Salman Khan does with the big boss consultant, and every weekend they do the weekend kawar. Okay, so we gone through such kind of weekend kawar sessions in my company against the with the boss, and it's difficult to answer those questions why services were getting freaked out, why it were failing, why it was not able to sustain the load, and what happenings there. So that is what I compared it like when you move to these microservices. Okay, and then if something get failed, okay, you compare it as a big boss environment. So you can see this one. So observability, it is very complex definitions. I don't understand. Okay, the simple thing is you can see this the song "Tak Te Rahe" to the chant. So where it's basically like you need to do the observability, keep watching microservices at 24x7 in simple word, and then for that whatever is required you do it. Okay, without any asking. Okay, and then there is no limit of implementing observability. Okay, it goes against your appetite. It goes against your how much you want to spend, how big you want to do it, how much data you want to retain it, and what is the business of nature. And the biggest thing is like, are you under in some kind of a compliance requirement, or kind of the SLA requirements when you serve to the client. So that all external parameters define the scope and implementation sides of your observability. Okay. And so when you see the observability, you have three things. Okay. The most important thing is you need to distributedly tracing and track your communications movement, how the one system connects to the another system goes to the connect to the database or the messaging systems, or do the data exchange to the each other. Okay, because what happens to the microservices, like you get the entry point somewhere from the API gateway, if we consider the HTTP APIs and REST APIs, and then from that point, okay, you need to check like when the API gateway invokes to the which microservices, and the microservice is connected to the database, or it's connected to the third-party system, and what is the latency between the API gateway and to your first microservices. Okay, and from the that microservice to the database, okay, what is the latency, okay, whether the queries are slow, okay, your messaging systems are slow, okay, and who is taking more time, and cumulatively if you sum up, your API requests are getting slow. So here that's why you need to do the distributed tracing. If you talk about the AWS, okay, the AWS has an X-ray. Then AWS, when you use the AWS load balancer, the AWS load balancer also, every request has the AWS request tracing ID. So those components are already putting those extra identifiers into the each and every communication calls. We need to keep passing those data to the one services to another services as part of your communication chain, and then this all the tokens is getting recorded, and then based on this token, the microservices platform can identify what is the response rate, okay, which service is failing, which service is scaling up, which service required more resources, okay, which service required less resources, okay, where you have a performance problem. So that all things can be identified with the distributed tracing. I'll show you how exactly it's look like. Another, the most important aspects which developer has to do it, but no one understand. Literally, I tell you, no one understand, because I have seen and worked with so many developers, so many companies, and spoke to many of the events. Okay, but no one come up with the, or no one knows about what to do with this logging. We are very different people. Everyone is very different. They have a different sense of English language understanding, vocabularies, and then whenever they write the logs, every person writes the log in their signature manner. And then if you have very large ecosystem and so many microservices works together, okay, and when something get failed, okay, you are only rely to the log messages that you have collected. But when you see the logs, okay, you pull your heads because you don't able to find anything important, anything sufficient to understand what happened to your applications, where is the failure, where is the success, what are the user statistics, okay, how the logs are related to the certain activity. You can identify it. So that is what the second point is. If you are seeing the proper, the modern programming frameworks, logging frameworks, for if you see the Java as an example, you see the Log4j. Log4j is probably pretty much everywhere in the entire Java ecosystem. Another is a logback, SLF4j, those ones. You also have Python logging components, or the other .NET logging component. .NET also has a log4.net, which is also like completely copy of the log4j. So those components have an inbuilt capacity called a message diagnostic context. It's basically the identifier that you put in the time of the logging, and then it would print as the key value pair there. And then those key value pairs can be used to on a such a way that it is a machine readable, and you can identify all those entities one by one. So I'll show you the exact practical example how you should do it, that one. And then this is how your application logging would get improved, and that it become a meaningful. Another one is application service monitoring. Pretty much everyone does it. Every IT company have either the Zabbix or the Nagios or or maybe some proprietary software monitoring system. It basically looks into your memories and CPU consumptions. If you are going one level of down and then deep into this particular topic, you will collect a lot of your application logs or your application events. Everyone does it, application monitoring. So we'll not go much depth into this one because it's like it's almost all ecosystem has that one. But we'll talk about the first two because those are the very crucial ones that everyone need to understand. So what is basically the distributed tracing looks like? So we already gave you the idea. It's kind of like the token which propagated to the request. So whenever requests get originated, that every request is being marked in with the one kind of a token, and token is being passed piece by piece to the all the subsequent get call, and then it get traced. When you trace those tokens, you can understand that the how the entire the software is being connected to each other. It gives you the tagging request unique identifier. It offers you the very near real-time visibility of your system. So I'll show that one also in the demo. The structure logging, yes, you must log your all application logging into the JSON only format, and you must implement the MDCs. I'll show that example because how what makes difference here. So consider like this is an example of your standard log message. Everyone must have seen this kind of log. Okay, so if you see this, the first line, it called user Ravi logged in, a very normal message. Okay, here I put the Ravi, my name is in a single quote. Then the someone some other applications. Okay, and this application is e-com payment applications. Okay, and then someone is add the log which is implementing the payment module. Okay, so what it does, like user Ravi making payment amount 10. So here the user is identified, but it's now in a double quote. So now we got a two variants. Similar thing in the third line. The same thing, the user Ravi checkout amount 10. I'm doing a checkout process, but here this log is written by third user, third developer, and put it on the double the square bracket. Similarly, you now have the fourth developer, and then he write everything with the equal sign. So Ravi user equal to Ravi logged out. So the simple message here, the fourth statement. But if you now want to analyze this and find the who the user included in this processing, okay, you need to add so many regex or so many manual graphing or the log visualizations. Okay, this is not the machine readable logs at all completely. And then you when you have a this kind of logs in the terabytes. Okay, we were in my previous company, we were sending the logs 100 gig logs every day. Just log messages, application log messages, and then the system log messages. And if I ask you to find certain events in 100 gig logs, simply not possible. No one can do it. And then the reason is the entire log is written like this one, which is completely screw the meaning of your application logging. And then it's just waste of time looking into this one. So now if you see the what is the MDC, okay. If you check this particular first line, okay. So it's the same line. You have the timestamp. You have the where exactly the log was originated. You have a thread which is a thread main. Severity is the info which is your log level. You have the class which originated the log message, and then you have a message. Message which basically user logged in. So that is the message, and then you have the MDC. So like if you see this, the key username is a Ravi, and the operation is a login. So this become now your operational keys. And subsequently, if you see this all other the below messages, you have operations payment, and then you have a one more key which is called amount 10. Okay. Here the same thing. You have severity 1, severity error. The user has the error message on the checkout. Okay, and then this one is failing. Okay. Then also you have the similar one, user logged out. The who is logged out. Then user Ravi is the logged out, and the operation is log out. So it's become you have here operation is log out is a 1, payment is a 2, and then login is the 3 operations. you have one more key, which is the amount. So every user and every checkout process have a different amount. It can be mentioned, and then who is doing it. So you can identify the user Ravi very clearly without any problem. And these logs are not the custom logs. These are just generated using the log4j and then the log back. You just need to configure those framework, and it would start generating this kind of a log, okay, right away, rather than the plain text logs. And you just send it to the any of the system which understands the JSON data, and then you make it this all meaningful. Application server monitoring, I'll show you what it looks like, but you just generally don't need to do it extra. Every system almost have this ones, but still we'll go it with the example. We speak about the OpenSearch. So what is the OpenSearch? OpenSearch is it's a large-scale data visualization platform. It's a search platform. Okay, if you know the Lucene, the Java search engine framework, Solar. So this is very similar to the Solar search engine, but this ecosystem was developed by the Elasticsearch. So that's why it's called the ELK, so Elastic, Logstash, and the Kibana. And then when the AWS started using the ELK and it provided the ELK-based services, they had the dispute, and then Oracle, the AWS forked out ELK state from the 7.12 version, and then they started making it and then making it as the OpenSearch. So the ELK comes now as a paid services. And then they have a lot of paid add-ons where the AWS OpenSearch is completely free. It's in a Apache license. And then it has all those the goodies that you require. Even you can build your entire search applications on this one. So you can build observability applications, monitoring, and alerting applications. And there is the large ecosystems now built over this particular software. It has one more component which is called AWS dashboard. So dashboard is nothing but the Kibana. So here they forked the Kibana and then made the AWS dashboards. And the things that is now a bit different here with the OpenSearch and the ELK stake is AWS had added, like it's still adding tons of the goodies to understand all set of AWS log messages outright. And so if you want to connect and then start ingesting all your AWS CloudWatch log messages, it would start processing it. And it understands all those the tokens and everything by default. So that's why it is more makes sense if you are developing and deploying something under the AWS, you use the OpenSearch rather than the ELK stack. These are some of the highlights. It's a way beyond this one, but it's a fast, scalable, full stack search engine. So if you want to make your own personalized search software, then you can use the OpenSearch. It's also does the application monitoring, infrastructure monitoring. You can do the security, event management, event processing. You can do operational health tracking with the matrices. You can train and execute the machine learning model to do the anomaly detection. I'll show you that how it does and how it helps particularly. There are when you talk about the observability is kind of built with the ecosystems of the various softwares. Okay, you need so many different components. Okay, to do a different set of jobs. There is no such a single piece of software can do it. There are softwares like proprietary, like if you consider the Datadog or you consider the Splunk or those components which are very expensive, but also they have their own agents and all tools that just provide you to do this activity. And then, but you pay more to those framework, and observability is very costly affair. I'll show you the economic once we do the demo, and then I'll share you my some of the learnings and then the cost factors and then all those other operational aspects, so you can understand the what you want to do and how we want to build it at the what scale. I'll just give you one example. My one friend works with the company in the US, and then they have a Datadog in as one of their observability platform, and they spend a huge money. It goes into millions of dollars as the cost of that observability. The company is very big and can afford it. but the observability tool costs the huge money. So whenever you ask a company to build it, or a company, that company need to be appetite, and they ask you what is my return of investment on this observability platform. So you need to understand like what exactly you want to do it, okay, what you want to find it, how you want to improve it. So there are so many benefits, but benefits are kind of like always get shadowed when you come up with the implementation cost. So that's why the observability is very. I don't see it much like people like upfront build it unless it's part of certain regulatory affairs, or you have are in some kind of SLS to the client, and then you build it. Here you use software which is called a telemetry. So OpenTelemetry is it's a very well known software, but here we don't use the OpenTelemetry. We use customized distribution which is called AWS distro for a telemetry, and then this distribution has so many extra goodies to understand the how software get bundle and then build it and run it over the AWS cloud. So they have a lot of extra things that comes together other than the plain open telemetry software. One more component which is very less spoken. People probably you won't even not find it even any blogs or any much helps here. That software is called a data preparer. You need this one, and AWS has built it. It's still it's getting matured, but it's a very less information is available. So when I was implementing this one, it took kind of good amount of time to understand how this particular software is working, and then what it does, and then why I need it, and how it works, how it get connected, and how it helps me to the process the data. So we'll go off this the tool in detail. Another tool is yes, the Logstash. AWS also has its own version of Logstash. You use lots of bits components. Bits basically it's still the elk stack file bit, metrics bits, hard bits. Basically, the file bit read files and then upload it to the OpenSearch. Metrics bits basically monitor your CPUs and all those the matrices of your operating system, and then send those tests. The hard bit basically do the health check to the certain URLs or certain endpoints and all those configuration, and then you have the heartbeat coming on, whether the it getting failed or not. So you can see and then do the uptime monitoring. So there are many other tools that you can use. Those ones. These are some of the tools that you definitely need. The file bit definitely you need it because when you build certain components and put it on the container or something, before the container get scaled down, we need to ship all those log messages out and accept it and send it to the observability platform. So that's why it's required. So file bit is one of the very good and small component. So this is one of the sample applications I have built it. A very small one. So you can see this the ecom main API. Basically, it's where all other APIs are published to the client. And then you have internal APIs, which one is the for a payment handling. One API is for a user handling, and then you have one API which is maintain the user's address, and this all data is stored into your one Postgres RDBMS in a very simple format. So what it does here, like whenever you invoke any APIs, it connects to the one of those APIs. You can see the arrows how it connects, and then it provides data to the client. So this is very simple applications in terms of microservices. But the thing is that here there is no observability layer implemented at all. Nothing here. But so how it looks like when you build the observability, and then why I say that the building microservices is not a big thing. You can definitely build it very easy microservices application development. But when you move microservices with the observability, okay, and then your platform looks like this one. It's the same system. Nothing changed. Everything is connected to exactly how it previously in the previous slides. But now here, this all is a Docker container which runs OpenTelemetry agent. So you add agent to the all container. So that is the first change. Then agent generates data and then send it to the blue line, which is a data preparer. Okay, you can see those the upper blue line and the below blue line, and then telemetry data goes to the AWS OpenSearch. So that is one your telemetry tracing. Now you have a logs tracing. So you can see this the red line and then red line. Every applications, every container is using one shared volume, Docker volume, and in Docker volume it writes the log messages. And then you have one more container which is just run the file bit, and this file bit it keep monitoring this Docker volume. So whatever the container produce the log, the file bit reads that log and send that data to the log stage. So you also have now a log stage in between bit, and then this log stage push the logs to the AWS OpenSearch. So you can see the difference how these simple applications that you operate it become such a complex piece of software. The thing is that you need a different software for a data paper, so you need to run it. So it costs additional. Then you also have AWS OpenSearch. So that is a extra software that you need to run it. So that is also cost. You need to run the logs test. That is extra software. That is also the cost extra. You run one more container to fetch the log from the shared volume and give it to the logs test. So 1, 2, 3, and the 4 extra softwares that you run, and also connect it to each other to collect the log at the OpenSearch with the trace data and everything together, and then it start building it. So that's why when you move to monolithic, if you go to my first slides, that elephant was alone, okay, and then one guy is sufficient to monitor the elephant. Now elephant becomes small animals, and every animals need its own maintenance and the housekeeping and the health and food requirements. So that doubles your infrastructure requirement upfront, because if container goes down, you need to ship the logs out. So someone has to go to the Docker volume and read the logs. And the biggest problem is this ecosystem works so behind the scene. So if someone has to do a manual investigation through the log messages, probably they would not able to find it in this environment. And that's why you add so many extra layer of software one by one, and then it's double your system requirements, and also makes everything is complex, because now you just don't care about your actual software, which is working well or not. Your software's health is also directly associated with the other softwares. Like you must need to also housekeeping of the log stage. You need to take care of the OpenSearch environment. You need to take care of data preparer environment, and this all other ecosystems and orchestra softwares need to work together, and then it produce the proper observability solutions. And so I have some of the dashboards, screenshots. I'll walk through the real ones. These are some of the ones that I collected last year when I was preparing this all demo. So you can see this like this ecom application has two APIs. So I'll call those ones and we'll see it. Then you can see how the API looks like. So you get two invocations. You can see the latencies and then average milliseconds, how it responds, uptime, downtime, error rates. Then you can see how many microservices are getting invoked. I have not feed any those data into this OpenSearch software. This everything is collected from the trace data which are supplied to the OpenSearch. So these are all automatic software collections happens, and then it start getting meaningful. You can see like if you see this the first line ecom main, it connect to the payment and the user. Now if you see the second service is payment, payment also connects to the main and the user. Now if you connect to the user service, the user connect to the main, payment, user, and the address. Then you have the user address service. It just connects to the user and doesn't have any other connections. So you can see how the each services are talk to each other. You can see this graph, how they are connected. This everything is prepared by itself based on the various trace data is being collected here. You can see the trace over the time, latencies, the call, throughput, error rate. You can. This is a very good detail. I'll show you how it looks like. But what it does is like when you invoke one API, and then this API takes suppose 2 seconds, 200 milliseconds. Okay, then it gives you the bifurcations which microservices take how much time to respond. And you can see this bifurcations in terms of here on the left hand side with the how it span from each and every layer to get your data. So I'll show in a practical ones. I have this one also. These are some of the links. You can find this presentations and everything in the AWS OpenSearch observability demo. I have everything is up to date running here. You need to go to the AWS OpenSearch, which is the main website where you get this OpenSearch software and all other documentations. AWS Hotel is basically the AWS distro of OpenTelemetry, which is the custom built software based on the telemetry software. So you should use this one. So you also see this aws.com/hotel where you can see more logs. There is one more component which is called a data preparer. This component is not published at large level. There are not detailed documentations are available. It is still under development, and so might over the time it become into the main ecosystem, and you would see it a lot. So the most difficult to understand this data preparer because there is no help available. You just do it trial and error. And this is the line where you see your documentations, but very limited. And so there are a lot of challenges. Any questions so far before we jump here? Anyone have any questions here?
Hey, Sajid. Hey, are you able to hear me?
Yes, very well.
Yeah, Ravi. Thanks for the session. My question is, when we use OpenTelemetry or ADOT from AWS, right? So it gives the capability of tracing and the metrics, right?
Yes.
But apart from that, still logging is in experimental phase. That's what I understand. Is it still available? Is it available for logging as well?
No, I'll show you because the telemetry does the bit differently than the log messages. The log messages still you need to read those log files. Then the file bit where you used it in between, and then goes there. So that's why you need the telemetry for a trace data where you need the file bits and log stays to publish the log data, and then those different channels the log are getting ingested to the OpenSearch.
Okay, in that context, if we use hotel ADOT, we need not to use the data prepper, right?
No, you need to use it because the hotel connects to the data preparer, and then data preparer goes into the system. So data preparer it's a bit of component which connects the hotel and the data preparer. I'll walk through that particular configuration how the things looks like.
Okay, sure. So if you can just focus on little bit in the last on manage the Grafana and Prometheus also to ingest hotel into that also will be good.
Yes, I can. We can spoke about that one. We have one more questions. How it works with the known API components. So what it does is basically these components, this like OpenTelemetry or OpenTelemetry distro, is basically doesn't need any kind of what we call the API engagements. Okay, the API invocation happens when it passes the test data over the HTTP protocol. You can also invoke it internally. There are different ways that the agent, the OpenTelemetry agents look into your piece of software, and then whatever works internally in between can extract out. So it doesn't necessarily that you must have the exposed API in a certain ways.
Okay.
Yeah.
Sure. Thanks.
But the another questions I have, it's a PIIs. I'll explain you what it happens, because if you see the way that I have modified the log message from the small plain text log messages where my name was included. Okay, it's become into the JSON file, and when you have the JSON as the output, I can give you the exact example. What you should do is, like, if you are a Java programmer and if you are using a log bag as a framework with a Spring Boot, a log bag has the extensions where you can configure what entity has to be masked. So still you produced your PIIs, if you are writing it, but when it does the output, okay, in the output, there's the PII will be masked like star, 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 or remove certain characters. So those kind of configurations that you can put it, add the log back as extension, and you can hide and remove and clean your PIIs before it goes there. I'll put this one practical example. I have built it in my company, so it does that one. It is not the responsibility of service team entirely, because it is a multi-layered approach. The way that we build it is uh, uh, there are developers involved, because developer has to rewrite the log messages entirely to make it more meaningful. Then you also need a service team, your IT team, to collect a lot of infrastructural components. Then your operating system logs collections, and there are a lot of infrastructural management and maintenance, and the tuning is happening here to transmit the log, collect the logs, and then only consider, even like from the AWS point of view, when you have the default AWS account, it doesn't produce the log, enough logs. Okay, but if you want to really tune it, then you will have a flood of logs that it can have that. Like the VPC flow logs. Okay, you open it and you will see how your systems get the TCP network traffics. Yeah. Yes, we build very detailed guidelines in my company at the various level, and that was mostly very custom to your environment, like how you build it. We had a very large environment, 200 plus servers, and so many things were going on. So we wanted to make sure everything is stay aligned and stay focused across the team. We had so many guidelines, tokens, entities, names, how you put it, how you write the logs, how it will be stored, how it will be fetched. Everything we made it so predictable with specifications fit to our environment, given to the every team, including the services team, and then everything was started synergic. And it took quite a 6 months from start to end to build the observability at the large scales. So I will show the actual working demo here. I'll just stop my presentation slides, and then we'll share my other component. Okay, I think I don't need. Where is this? Okay, this is gone. Well, so let me share my screen entirely. So we can go with the demo. Okay, I have one screen. So now I need to share the entire screen. Okay, share it. So let me first jump to the project structure, so we can go over it. Okay, I can show it here. It's the same thing. Okay, so this is my GitHub repo, which is I'm demonstrating it. It has all required detailed configuration files. Okay, so these are the like ecom commons, JPA, main, payment, and address and user. These are basically considered your small microservices, which has HTTP REST APIs. I also
Ravi,
have.
it's blurry. I think if you want, you can turn off your video, and then I think we can just have that.
Sure, yeah,
screen.
that would be a good idea. Okay, that would be good. Now it looks good. Hello.
Still the same, but I think should be okay. I think you can proceed.
Okay, let me zoom also.
Yeah, it's better now. Yeah.
Yeah, I added to zoom it. I have very detailed resolutions, very large resolutions. Okay, so this all folders basically are those individual microservices. This is a complete fully Java Spring Boot project. I have lots of diagrams here, so you can also look into that one. I have all your configurations here, data prepare configurations, pipelines. You have all Docker Compose that it gets start, including file build, log size, OpenTelemetries, and the POM. So this is something like full-fledged working project. I have two rules here to test it here. That you just want to execute it and then it start running it. So this is a code base. Whoever want to try it can fork it, check out it, and if you need any help, want to deep dive, then you can just post the questions and I'll try to help you out and then help you in the adopt. So here I think, how it visible?
Yes,
Okay. So let me just walk through a couple of important things, okay, before we jump. Okay. And so let me start with this OpenSearch. So this is the AWS OpenSearch. So I have a Docker Compose here, which is 2.10, which is the latest one. And I have some of the different configuration. I just run the one node cluster, and I have the 9200 port and 9600 port for this one. So this is standard configurations. The second one is I have a dashboard, which is basically the Kibana, and Kibana connects to the network where you have a OpenSearch node 1. So you have a connection string here, so to get it connected. I have a Logstash, and Logstash is also connected with this. It's a Logstash pipeline, so I'll walk through the pipeline, and then and also it depends on the node 1. Basically, the Logstash also connect to the OpenSearch node 1 to push the data. So this is the one set of configurations. I have one more set of configurations, which is data preparer, which is data preparer 2.5.0, which is the latest one that I took it. And it has the pipeline and the configurations. One, basically those two are interested one. Where is those one? Yeah. So configuration, nothing. I don't have any SSL set it up, so it just made it false. The pipeline is a very important factor. So it's what it does is basically you need to define what is the source of trace. So source is OpenTelemetry source, and then it has a sink basically where you want to throw it out. Okay, so how you receive the data, where it comes from in a what format, and then where it goes. So I have a two sink written here. One is the raw pipeline, and then one of the service map pipeline. So raw pipeline is basically goes to the OpenSearch here, sync output, and then this is all my credentials, and this is a trace analysis row. These are basically some kind of pre-identified details that you put it. So it put the data in the correct place in the OpenSearch, and then OpenSearch understand very well. So there is kind of like very dependent connected environment here. Another one is the service pipeline. So you have a trace analytics service map. So basically these are the indexes where the data has to be pushed into the OpenSearch. So that's why the data people is required to receive the data and then give it to the OpenSearch. And this is the component. This is also a Java component. And it took me quite a while to figure out this entire configurations. So this is the one. The another one we have it here is so data paper we've gone through. We have OpenTelemetry, and then we have a so not this one. Oh, yeah, this one. So I have a one logs test configuration file. So if we go here, so what it does is like I have a log file which is run on the 5400 port. It have a log test how it need to get if the com is in the tag, then you need to process the JSON data from the message. Okay, if if Tomcat access log into the tag, then you extract out message from your this one. You have a timestamp in this format. Okay, you also need to source the user agent, and then so once these are the tags and processes are done, you send the output to the node 1 of the OpenSearch. So here the thing is that you can have so many different kind of the input from the file bit, and once you have those file bits are sending the data, you can tag all individual files here, and then based on that you can do all kind of custom processing. And so consider you have the Linux log, operating systems log, your database logs, your access logs, you have a LDAP, you get the LDAP logs, FTP logs, whatever log messages that you have it, you can configure file bit to read those log files, send it here, you apply processing chain here, and then you send it to the OpenSearch. And so these are the two crucial components to transit the data. I have an OpenSearch, the file bit configurations. So what file bit does is basically it has output to the log stage. This is my host name, so it sends data to the 5444 port. Then these are some of the metadata tag forwarders and all those ones with basic configurations. And somewhere I put it where to read the files. So it read the files, this log stage, and then it start sending the data. Yes. So you can see this one, the file inputs in the log stage. Okay, so I have a file systems. You have the ID ones. You read this your Tomcat path. Okay, then you tag it ecom. You if the type is log access enabled, you read this your access log files and tag it to this one. So this tag is directly edit here, and then based on that you can do the if and else and all kind of customized log processing, matching, identifying, date processing capacities. So this how the entire ecosystem works. I'll show you one more thing here. Consider this is the main applications. Okay, and the main application. Yes. So I use this a Jeep Maven plugin, which is basically the Maven plugin which build a Docker container as part of your Maven build process. So once it's built, I use also the Java agent and then put it OpenTelemetry agent jar file as in my application. So when it start collecting all the telemetry data from right away from the JVM, and then whatever happens to my JVM, it just extract out. And if you see the like all third-party components and libraries, they also have so many internal telemetry points which directly start working together without doing any configuration. So I have not done any further manual configurations to the OpenTelemetry agent. But when you put it as the agent, this jar file, it starts just doing a magic here. So this all built, I have a containers, and when the container looks like, I have started it here now. So if you see this, the first here, this run AWS OpenSearch node, and it's keep running, reloading, and this one. And then you on the left hand side, this is my ecom main applications. I already figured out I did some kind of wrong inputs to generate specific the errors, and then that error will be logs to the applications. I have a this one is a data preparer. I'm running this data preparer in a separate separate kind of Docker Compose. The reason is that there is one bug I reported where this all components are each other dependent. Data prepare starts so aggressive, and if the OpenSearch take a bit more time in the running and at starting, then the data preparer component get failed, and it doesn't have a mechanism to reconnect it to the OpenSearch. And so there is a bug reported by me, and many other guy have see that there is the bug and they are fixing it. So that's why I need to start it OpenSearch first, then data preparer, and then my applications in a Docker Compose. And then when it's start ready, I can start invoking the URL. So I have it here. I find it how to do it. What was? Can you see this one?
Yes.
Hello? Okay.
Yeah.
I think one more. Now it's visible. Okay. And so I have built this simple URL, 2 URLs only, nothing much. But when I invoke it, okay, what happens? A list. Okay, it's not a list, but it is list. Okay. And so the first one is failure. You can see this. I have HTTP 400 because I execute the wrong URL. Okay. And then this one is success because I execute the correct URL, which is a list. And now I see there is a one user. I put it in the manual. So user comes from the user table, from the user services, and this address comes from the user address services. And then this is my address, and then it got print. So when we go to the AWS search now, AWS OpenSearch, okay, what you look like, okay. So this is the screen, the login screen. Okay, it runs on the 5600, 5601. You do a login. So it comes with a very blank screen. This is a very neat and clean setup I have done for this particular demo. And it has lots of configurations. It also comes with some kind of preloaded sample data. Okay, like if you see this one here, okay, sample data ingest. Okay, so if you want to see like how the AWS OpenSearch helps to build various things, you can do it with this one. Let me also zoom this one. Is it visible?
Yeah.
Okay. So you can load it sample data if you do not have such a large amount of data, and then you still want to play with this one. Okay. So this is a simple e-commerce website data, and then there is the flight simulator, and this is your logs or web server logs data, like your HTTP access logs. So you can just add this data, and then it would have the entire dashboards and everything is ready. You can play this one. So I have not set this one, but I have my own application. So we'll go to the dashboard. So this is the dashboard screen. I have built the dashboard here. Okay. So this is the ecom dashboard. And when I build it here, I have last 15 minutes. I have a one 200 and one 400. But if I just go to not absolute, but maybe 3 hours. Okay. 3 hours now and update. No, not 3 minutes. 3 hours ago. So you can see this one. So I was already playing even before this demo, and I pushed the data, near real-time data, and then I collected it. So these are the HTTP code. You can see this one. This comes from the Tomcat logs. There is a 1400 404 because I made the wrong request. Then I made internal server error because data was not available, but the API was correct. So this is the 500, and there is a HTTP 200. So you can see this data is getting come here real time. And then I have one more URL that I have this one. And if you see if you execute it here, let me execute one more. Okay, you can see what I execute. Okay, so it will start coming it here. Okay, there is one more one. Okay, so there is a one more payment URL. Let me just. You can see here this box has got rejected here now. So it generated the data, then the file stage pick the data, and it start sending the data. We'll just put it here. Okay, now it's visible. Now I'm making one more payment. Maybe like let me put it on 4,000. So by making the name Ravi. So Ravi is making a payment of 4,000. Okay. Okay. This one. Okay. This looks good. What is the bad request here?
The ampersand is missing. I think.
Yes, and person is missing. But this is a very good example. We'll see this all trace records. Okay, so now it's done. Okay, I spend the amount 400. I'll see something, one more. I'll see something very big number. Okay, you see this log stage is now getting reacted, all those data. Now, when we go here, okay, and just let refresh. Okay, see, I see now 400. So that is my failure. I see the near real time. I made 4,000 payment. I made 4,000 some bigger number payment. I made, so these are everything, and these are all my trace data, which comes here directly. So this is a dashboard, and you can build so many further visualizations. I built it here. So like if you want to build it, you just go here, you check your various visualizations chart, collect the data, and then you just start putting it here, that one, and then you build the dashboard. But if you want to see the actual real logs, so how the logs look like. So there is sections called a discover. Okay, and so this discover is looking all my file bits log messages here. You can see my log ingest timing. So I started working at 9:30, and then again I did some counts, and then again now we are doing some counts here. So you can see this one, and this is my individual log messages. You can look here. So you can see this is the AWS Extra Trace ID here. You can see my HTTP logs threads. You can see timestamp where it comes from, my agent IDs, and then so much detail. I think let me open it here. Okay, so finding severity info. You have a AWS Trace ID because of this is AWS telemetry tool which generates that one. That tool is modified to directly connect and work with the AWS. So that's why you have that one. Okay, ecom user is something which is doing a trace and span. So you can see this all entire request configuration here. Okay, you can. This is my class name which generating the span now. So you can see this one, the log file where it reads it, and then pretty much every detail you that comes here, you have it here, and based on that, it generates the data. Now, if you so this is too much. Okay, let me drill down now. So these are my MDCs entry. Okay, so now last name and first name. Okay, user ID, last name, Then what you had here, there was okay, there is e-commerce payment and there is e-commerce operations. So you can see these are all data which come from my application log messages. So now you have these entities, and these entities can be filtered it out right away because those are the JSON entities, and you can mask it literally completely. Though you can maybe keep username, user ID here because you want to identify it. You can see this payment. You can see like this is a get user. You have the make payment. You can see this all data here. And then you can keep go on. Okay, I made so many requests. So you can analyze who is doing what kind of activity just from your application log file. So this is how your MDC based log is look like. One more thing we want to see that is the observability now. So this is application log monitoring. You can build n number of dashboards for your systems. Now, when you go to the observability sections here, I have created one application, which is my ecom. And if you see internally, it just starts seeing that I have those many services. Those services are identified right away from how my data is getting pushed here. It connected from ecom is the main service which starting point. Then it connected to the payment, then goes to the user and goes to the address. So how this my services looks like. You can have the error rates here, okay, and then you have request rates here. Then you also have here the trace groups. You can see my select ecom star. These are all my queries data. You can see my average durations, 24-hour trends. It's getting up, it's getting down. So you can do the trend visibility. You can see your rate times, trace times. So this all comes by default. You don't do anything. You just collect it and then push the data. When you go to this span, you see each and every request is have a spans and the trace logs. So let's see this list one. So this is the list API. You can see entire your configuration details one by one. Ecom Java applications, what it does, how it invoked. It's cruel invoke, which APIs, my server internal IPs, network stays, then everything. So you have that one. I need to show you. Not the log. When I opened, you have trace. Okay. So we come to the trace. We increase it to 5. So here your trace. Okay, let's see the first trace. Okay, we open it. So this is now we're talking about the individual request. A request is it's a payment request, and so this is this is the payment request here. You can see this one API/payment, and these are the parameters that I have passed in. So this is the one payment request. Okay, it took this is the latency. There is no error, so this is a success request. Now you can see the distribution of the individual call, how it looks like. So this took 800 ms to end-to-end executions here, and then now from 800 ms, 789 ms took by the make payment API, which is the main. Then it invoked by the GET request. Then now here it goes to the payment services. So you can see the color is being changed here. And then from the payment services, it need to find the user. So it's connected to the COM user services, and the 500 milliseconds took by that one. From that COM user, it's the find user. Then this is the command. Then you can see this my JPA repository is being invoked. From that, here it invoked my select queries. Okay, then you have this is my transaction commit in 7 milliseconds. Then a user responded this address. Then user also goes to the find the address. So it also connected to the address. It does the select, and then here it does the commit transactions. Okay, so you can see that it talks to your JPA layer, then it goes to the controller layer, it goes to your database layer. Okay, and then it shows you the how much time the query is being executed. So this is the detail where it shows you what it does internally. Yeah, so operation select address. So this is what it does, and then it goes, and then it connects to the database, then it completes the transactions. Here it connects to the my JPA repository. The operation is JPA repository find name and the address ones, and then how the span distribution looks like, what the individual method and the command it's take to have in a total 800 ms execution time. So in this bifurcations, you can now see how it looks like basically, and then what it does internally, and where you want to improve the performance. Okay, if there is a bottleneck, some is taking more time because the overall your microservices actual execution time is some of the slowest component. So you can see where you want to improve it, and how the things will work. So this is the real trace of end-to-end executions till the database. It still goes to the very detailed level. And if you have any other third-party like messaging systems, or you connect it, it just track everything, and then you just don't need to do anything extra to get this kind of a detail. So this is the observability state. It also has one more. I think I have not said the matrix right. So this is the empty. I want to show you one more thing that is very important. You have reporting plugin. So here you can do the alerts when the alert is being generated. You can do the reporting and investigations within the system and create the entire investigation reports with all your artifacts. This is the one. I think you can have the visualizations notebook, and then you can generate the PDF and everything. So it can help you to investigate the problem from here. One more important thing that we have used a lot, and that is the anomaly detection. So this is very important tool that comes here, which does have internal the machine learning module. What it does basically, like as you are keep flooding the data, okay, you have so many systems, you are keep sending the data on every second. Consider, let me take you to this one. Okay. So this is my payment example. Okay, and then this is let go by Hava. Okay, so this is considered this is my e-commerce payment analysis. Generally, if you see, I sell the item which is $400, and suddenly I have someone which is put the order of 400 and a very large number. So this is not basically the error, but this is the anomaly of my usual selling in my e-commerce website. And then what I need to do is I need to configure this findings to my anomaly detection tool here. I did something. Yes. Oh, yeah. That's great. Okay. So now I have a one anomaly reported here. I can see something, and then you can see this one. Then you can investigate this one detected. So view the result, what it's detected here. Instagram. So it should have the details. Yes, so this is the real-time data. You have one anomaly, which is certain and a half of the grade. you can investigate and see. You can alert what this anomaly is, and then you can go and then verify your anomaly, that you have very high number of payments are happening, or something is unusual is happening into your system, and based on that unusual activity, you can work, and then you can investigate with the full detail. Okay, so these are not the basically the errors, but it is something which is going weird in system, and this everything is done by your machine learning model internally. So you put as much as more data into the system, it will be trained automatically on the daily basis, and then it get matured, and it can predict that you might have a downtime. Okay, or consider you selling 500 record 500 items per hour, and suddenly you spike it to the 5,000 items of per hour, or you see the normal rate is 500, and then you see a drop of 50. Okay, so that means something is going very weird than your estimation systems, and then you need to go and investigate. So this is the real-time anomaly systems that you can work on. You can configure it, and then you can see how detailed you want to do it. This everything is like based on the query that you put it here, rather than anything. So if you stop and proceed. So what I have done is I have put the source of data. I put my time field, and then I put my configurations here basically, and then we just start doing machine learning in the near real time. So you get this anomaly detector. So if you see this code, like how actually the code is looks like now, and what is internally happens, consider this is my main applications in the Java code. You come here, okay, and then this is my one. This is my REST API. Okay, so I have a payment controller. So we spoke about the MDCs. Okay, so what this MDCs is doing here? Okay, if you see this one, okay, I have used this SLF4J here, and I put the MDC class. I created my MDC token, put MDC operations. Okay, so this is my operations amount, and then I logged message, and then I done the MDC clear. So what it does, like this message would actually generate all this 4 MDC put messages as individual JSON keys, and then I can process this all JSON keys directly into this one. So you can see this one, the fields. This one, this, this. Yep. So these are all my MDC keys that you can see it here, which I have put as part of my log message. Okay, so this is my plain message, and then all these MDC keys can be cleaned out and then can be sanitized by external system, and then still you will have your log message intact, and then it's still working fine. Yep, sorry for that. Yeah. So this is how you sanitize the log message. You push it this ecosystem, then you make this all charting based on all your data that you collected. I build it to this is the HTTP code. This is my payment numbers. You can build a number of graphs here. This is a near real time. Then based on that one, you can do your observability. So we've gone through this whole observability. It just looks connect all web services internally, trace error rates. You can see there are error rates are responded here. You can monitor it with the detail. Then also you can do this anomaly detections live. So when anomaly is detected, you can investigate that one. You can prepare the investigation report records here. You can do the alerting. So now you can create the monitored session here. Okay, per query monitor visual editor by interval 1 minute data source file file bit star. Okay, you have time field. Okay, query. You can add the filters, group by, and then you add the triggers, and then you have the alerting. If someone does something, it can send the message. It can connect to the all sets of alerting ecosystems that you can do it. Also, you can use this one if you use this one. Wazoo. WS Wazoo. So Wazoo is again the open source XDR platform, completely very powerful. It has the agent and it has endpoint detection, threat intelligence, securities. What it does basically, if you see the screen is very similar to your OpenSearch dashboard screen because those are very tightly connected to each other. Wazoo can you can feed the logs to the Wazoo, or you can feed the logs to the OpenSearch. Then OpenSearch can connect to the Wazoo. The Wazoo agents are deployed to the individual Linux. Now consider the scenario: someone tried to break in into the your Linux box. Okay, like consider. Let me show you what exactly it looks like. Okay, sudo minus I. Okay, so it asked me password. I gave a wrong password. Again, wrong password. Again, wrong password. So I made 3 attempts here. Uh, uh, okay, now sudo minus I. Voila. So you see all these kernel logs here. So you will get this all logs here. Okay, you will see certain my associate failures. You can send all those logs to the system. Then you can process these logs. Then whenever you see certain anomaly to here, say sudo. Okay, R Sony made incorrect password attempt 3 times. Password root bin bash. So I can get this data. I can send it to the OpenSearch. OpenSearch can detect this event, ask Wazoo, go to that system where the event is come from and block this user. So this kind of you have also automated operations can be built with the OpenSearch, and then you can operate it at with the Wazoo as well as with the OpenSearch. If you just want to not to have the observability platform, but observability and the security platform with the OpenSearch, and then this both can combine, and then you have end-to-end the proactive security mechanism implemented. So you observe it, but also you do the activity. And the Wazoo has just not for the one event; it has a lot more the actions that you can take it upfront, and then you can self monitor and self manage the your entire observability systems end to end. So I'm almost done with my the demo and the sessions, and I'm open for the questions here. Any questions?
Anyone has questions on the topic?
I hope that like I meet the criteria and parameters of showing something which is useful, and then you can use this whole project which I put it on the GitHub can help you to implement your observability platform with this ecosystem. It's a bit tricky because it has a lot of components, but still it has the enough components to go on.
Not as a question, Ravi. I think microservices, this is we run using different components, right? Some can be run as a container. Some I've seen even people running an EC2 instance and exposing the API. They're actually running an EC2 instance as well. And some could be running in other cloud as well. So like multi-cloud as well. So the API could be running in Azure or other cloud vendors. So I think the open source tools could help us to bring all those log data and show it, and then outside of one particular vendor, you're taking all those logs and then showing it in totally outside of that, and as an open source tool we could use and then project it or do the observability outside of one particular vendor.
Yes, we had a vendor locking with the Splunk. It was a bit costly, so we moved to the OpenSearch. There is no vendor locking here. Everything is the free software with the Apache license. You can completely stay out. Everything is available over the source code, so you can fix it, the code. I also have fixed so many bugs in this ecosystem when I was started working it. There are always something which doesn't work, and then you go and raise the PR if you know that ecosystem and how you fix it, or at least you help them to give the sample examples and kind of reproducibility of certain bugs, so they can fix it. So I do a lot of contributions to that level where if I'm not able to fix it, I'll prepare the entire self-contained demo and will give them examples to fetch the repo, test it, and then reproduce the bugs, so it can be delivered. But yeah, definitely the open source ecosystems, and this software works everywhere. Okay, I'm running in my laptop with the containers. You can host it on the AWS. You can go with the GCPs. You can have this everything with within your Kubernetes environment anywhere. Yeah. And it is the ecosystem basically. So like if you were like we spoke about the Prometheus and the Grafana's, so that also many tools now generate the Prometheus test analysis data which stored to the Prometheus, and then Grafana you fetch that one. So that the Prometheus and Grafana were built towards more do the container activity monitoring and then those ones with the infrastructure level, where the observability is not just your Prometheus and Grafana. You also need to know what happens within your applications. So we had the multi-layer approach in my company where we put entire Linux operating system logs into the OpenSearch, like including FTPs, LDAPs, and database logs. Everything, even you do the SSH, and then it would report it to the AWS. Then we open the AWS all floodgates. So VPC flow logs and everything is there. And then whenever some requests get into the AWS environment, we started tracing of all those activity till end-to-end to our application. So it is already there. What we had another one. Yes, the applications, we modified all our applications to produce the JSON logs. So we can collect it and we can correlate with the JSON logs in terms of the activity, API gateway logs to your networking logs, which server is producing. And so as much as logs that you have, you need to build it. You also need to make sure that you use the common entities and identifier across the environment. So if someone is sending the log from one server, okay, then the IP address must be into the field of IP address. There is something called a common schema model that also I must point it here. What the common schema model is basically, you have so many systems generate the different sets of logs. So to make sure that your A system logs is related to the B system logs, and it is only possible when you have the common entities in both the places. Okay, consider the IP address. So IP address must be come in exact same format with the same key name from multiple sources of your log of the one server. So you can take one IP address and find what happened to this entire server and how it's responding to the various activities. So there is something called a common schema model, which everyone should look. And then according to that common schema model, there are standard models which you use it, and then you extend it and build your custom schema model for your applications and for your personal requirements, and then follow that models to generate the logs and push the logs to the OpenSearch. So once you have that standardizations available across the systems, these tools give you a